Hi Pankhurst, and welcome to your second science lesson this week. So today is Wednesday the 10th of February 2021 and our learning objective is can I explain what I have learned about magnets. So now, this morning we had a really interesting live session. Okay, it was a bit different to what we usually do. So today I had given you some questions about electromagnets and you had told me what electromagnets are. Okay, so an electromagnet is a magnet that runs on electricity, and the way it works is by a coil. Okay, so the coil, once it gets electricity in it, then the coil turns into a magnet. Okay, so now in our lesson today, we will be explaining what we have learned so far. So today is our last lesson on magnets. It's been such an exciting unit to learn about. I'm sure you all have learned a lot. At the beginning of this term, we did a KWL chart and a map. Okay, so brainstorm, where we spoke or we wrote about what we already know and what we want to know. In today's lesson, we will recap on everything and discuss about what we've learnt. So now, this is what week one was about. In week one, we did a mind map and were introduced to our key vocabulary. Okay, so now this is the mind map that you had done. So you should have answered these questions on the side, okay, that we had here, and a lot of children did. Okay, we learned about the different, we learned about basically that this object is a magnet. We learned about our key vocabulary. So our key vocabulary for week one, which we should have used throughout our unit, were magnets, poles, forces, attract, north, south, friction, and repel. Now, put your thinking caps on and I want you to think about this question. Do you remember what the words mean? Okay, pause the screen now and think about what the words mean. Okay, fantastic. So now this page shows you the meanings of the words that you just looked at. Okay, so now let's look at the first word, which says magnets. Now this is a magnet. And if you follow the arrow, it says magnets are objects with magnetic fields that pull or push magnetic materials towards or away from it. So magnets are these objects which have magnetic fields. Okay. Poles, it's one of the two ends of a magnet where the magnetism is found. So these are the poles. It's the two ends where the magnetism is found. Okay. South is usually the blue part, end of the magnet where the magnetism is found. North is usually the red part, so this part, okay. Forces are motions of a push and a pull of an object, okay. Repel is when something moves away from the object, okay. That's repelling. It won't attract, okay. And then attract is when something attracts to a magnet, okay? When it comes towards a magnet, it attracts. And friction is when a force that acts in the opposite direction to the way an object wants to slide. So friction is when they're two opposite directions. Now, in week two, so this is week two, we learned about two types of forces and did an experiment on friction at home. So we did an experiment on friction at home, okay? Now, do you remember what a friction is? Do you remember what a friction is? Put your thinking caps on and have a good think. What is a friction? So friction is a force that holds back the movement of an object. Friction acts in the opposite direction to the movement of an object. So when you, now let's pretend my hand, so you've got a pen and you've got a magnet. Friction is when they move on opposite directions. Now, While I'm trying this pen, it's got quite a tight friction, which means the pen isn't sliding easily off the magnet. And during this week, week 2, we learned about a push, a pull, and we looked at this man on a bicycle and discussed what the friction was like when he was moving on different surfaces. Week 3, this week you were introduced to magnets, different magnet shapes, and learn how magnets have 2 poles. So we were introduced to magnets. Do you remember I said I would have laid the table out really nice for you in school with loads of magnets for you to explore, and we didn't get a chance to do that. And then I just showed you different types of magnets. So here you've got a magnet. The red side is the north side and the blue side is the south side. Then if you look at this picture, it shows when you have 2 opposite sides of the magnet coming towards each other, they attract. When you have 2 of the same sides of the magnet touching each other, they repel. Okay, the magnetic fields don't allow them to attract. Then we looked at the different shapes of magnets. You have a bar magnet, and that's what we usually use in school. You have a cylindrical magnet, you have a U-shaped magnet, you have a horse-shaped magnet, you have a circular magnet, and a ring magnet. Okay, then you've got week 4. Okay, week 4. In week 4, we carried out an investigation and learned what working scientifically means. So I had done the investigation for you, but I did give some of you an option to do it at home if you were able to. So if you had magnets at home. So we learned what working scientifically means, and we said this means using the processes of science. The science has different processes. You question, you try and work things out by doing experiments, then you try to find evidence, and then you collect data, okay? And we looked at the different processes. So the different processes in science are aim, prediction, method, resources, variable and fair test, results, conclusion, and evaluation. Now, I want you to put your thinking caps on, okay? And I want you to tell me what each of those words means. What does aim mean? What does method mean? What does fair test mean? Okay? And then come back to my screen when you are ready. Okay, fantastic. So aim is what you're trying to find out. Prediction is what you think will happen. So it's where if you think that all metals are magnetic, or you think all metals aren't magnetic. How you will carry, method is how you will carry out the investigation. Resources are the equipment you will use. Variable and fair test. Variable is something that can be changed. A fair test is something that stays the same and consistent to make the investigation fair. Results are what did you observe or see happen. Conclusion is what did you find out. And evaluation is what is a fair test, what went well, and what could you investigate next. So last week, which was week 5, we looked at the strengths of magnets and magnetic fields. Yeah, I had done an experiment for you where we were trying to find out the strength of a magnet, of 2 different magnets, by attaching paper clips to it. And I didn't attach paper clips all around it. I was attaching paper clips to it in a chain. And the reason I was attaching the paper clips in a chain was to see which magnet was stronger by attracting a paper clip from the furthest, with the paper clip that was the furthest away. We looked at how magnetic fields are around the magnet, and we discussed how iron fillings show you the alignment of magnets. We also spoke about how the Earth is a massive magnet itself. And what Earth does with its magnetism is it protects us from the sun. Yeah? Now, the magnetic field is the area around a magnet in which there is a magnetic force. Moving electrical charges can make a magnetic field. Okay? So, the north side of the magnetic points towards the Earth's magnetic north pole. Okay, so if you look at that. So when you have, for example, a compass, the arrow which is freely run on a compass will always point to the north side of the Earth. The magnetic field sometimes flips and south becomes north and north becomes south. The magnetic field protects us from the sun. Now, we are in week 6 currently, and we've only done yesterday's lesson so far. So in yesterday's lesson, we looked at magnets and their everyday uses. Okay, you come into contact with magnets many times in the course of your daily life. They play an important role in a wide range of devices, like you saw yesterday, okay, and like these ones here, including simple toys, computers, credit cards, hospital machines, and business equipment. So if you look over here, you can see that televisions, computers, and ovens and fridges all run on magnetism, and also roller coasters and trains, and even a cow. A cow has to eat a magnet because when it eats its grass, any metal that it picks up gets attracted to that magnet. Okay? So I do actually hope you enjoyed this unit because I definitely did. Now, these are your tasks. Your task today is to provide your peers with information about magnets. So you are going to be creating a piece of work that will give other people information about magnets. There are 2 ways you can do this. You can either do a poster or a brochure. Both these documents give information. I will show you some examples and talk you through them on the next page. Okay. Now, as an extension, I would want you to do this. If you have done a poster or a brochure, as an extension, I would like you to record yourself presenting it. So what you will do is you will pick up your poster and you will talk through your poster. So you're going to present it and explain it to the people. Okay. Now, this is a poster. A poster has a heading, a subheading, facts and information, and pictures. Now the subheading gives you, now underneath the subheading you will talk about a particular topic. So for example, if your heading is magnets, as a subheading you could have daily uses of magnets, and underneath that you will talk about everything on your day-to-day life that uses magnets. Okay, you will include pictures and facts and information. And you will use your knowledge over the last few that you've gained over the last few weeks to add information to your poster. Now, a brochure looks like this. With the brochure, it's a folded piece of paper. Yeah, it's like a leaflet. So if you look over here, it's folded in half. So the way you can do it is get a piece of paper and half it, but make sure it's landscape. Okay. So you half it and you had different information on different sides. So on a brochure, your front cover would be pictures and you could write down magnets as a heading. Inside you would have subheadings and headings and facts and information. Okay, so now this is what brochures look like and this is what a poster looks like. Okay, now what you can do is you can pause the screen on a brochure, or you can pause the screen on poster and use this as an example to help you create your information piece. Okay, now once you have done that, if you can you please do the extension where you are recording yourself presenting your poster or brochure. Okay, I look forward to seeing all of this on Tapestry, and I shall see you in your next lesson, Pankhurst. Bye.